this is a great question, then you'd have to round right after that 3. And you have to say, okay, after the 3, we have to cut off the rest of this number. And since it's still, these are still places to be represented, they have to be held by something. We're just going to put zeros there. So they are not significant at all. We just have 2 significant figures here, and those are just cut off. They're amputated. They're cut off.
The first one.
This one?
It was 0.1 in the end.
If it was 0.1?
Yeah. Do you have to like make it 0, or can we just like?
If you had to round this to 2 sig figs again, right? We still, that would all be cut off. Doesn't matter. This could be in your calculator. It could be 7767.
Yeah. Do we have to put 0.0 in the answer, or just 2300?
In your answer, if this is rounded to 2 sig figs, this is it. You don't put any decimal place. You just put 00. Yeah.
So going back to that 2325.1.
Yeah.
And we want to significant figures. Can we put 23 only, or
Not just 23.
2300?
Yes, that's what you have to put. Or, alternatively, you could put this as, if it makes you feel better and warm and fuzzy, you can put e to the, what did this be? 3.
3.
2.3 e to the 3, because you have 2.3, so that's 1, 2, 3, that's what it is. So that way it shows you that there's 2 significant figures, and you move the decimal place 3 places. This can also be shown 2.3 times 10 to the 3rd, if you like.
That's an argument, even if you don't have scientific notation.
Yeah, you could still do that, if that makes you more comfortable than this. You could report all of your answers in scientific notation if you wanted to. You can even make a funny face. Okay. All right, you had a question?
You just answered it.
Okay.
Good job.
Do we get a question like the last one on the test we had?
What was the last one?
A really hard one. Tommy has a balloon and it's exactly.
Oh, yeah.
What's the mass? Still floating in the air.
Yeah.
Okay.
Do we get like that one?
Oh, yeah. Well, I think that one is just, it's weird because of the way it's phrased. I think that's the reason why we kind of got that one wrong.
I got to know, like I got 0.5, like, had it off from it, but I still don't understand why. Like, I know I just mean wrong, I know it's wrong, but I don't know why it's like that.
You don't know why the answer is the way it is?
Yes.
Okay.
Yeah, like this setup, like,
Set up.
I did 1.204 kilograms of meters cubed. And then, like, I got the right number answer, but the decimal was like 4 places off.
I got you. Okay. Wow. We did a little bit of scientific notation. Do you guys want to do any more scientific notation?
Suzanne?
Yeah.
Do we have to memorize the mega giga?
No, that'll be given to you.
Okay.
There's a little answer sheet. I'll print it off for you too. You came in a little bit. It's okay. Came in a little bit late. I'll show you that in just a second. Classifying matter are these things that let's just talk about these really quick, and then we'll dive into that question. Okay. All right. So classifying matter. Classifying matter is just. There's not going to be much. There's not going to be many questions about this, and the questions I ask you are going to be somewhat easy.
Like true or false.
It'll be like true or false. It'll be like, it's just knowing that all matter, comes in 2 different forms. One form is a substance and one form is a mixture. The substances, they can't be physically separated. You can't physically take them apart. That's a substance. And a substance can be either an element or a compound. Elements are just those individual elements up there, like carbon, nitrogen, oxygen, fluorine, neon, all that stuff. Those are elements. The compounds are stuff like water, H2O. They're 2 elements or more elements stuck together. You can't physically take those apart. You can chemically take them apart, but you can't physically take them apart. Okay? They're somewhat different.
What was the opposite of substance?
The opposite of a substance is a mixture. It's just 2 or more substances put together, and you can separate those. So let's say we take one substance, let's call it H2O or water, and let's put another substance with it. Okay? Let's put salt. Let's put NaCl. together with it. If you put those two together, you can mix them around a lot, and you can also take them apart. You can take them apart by like boiling off the water, and the salt will stay back. And so that way you can physically separate them. But chemically, they don't change. The
What
parts
about
don't
if you
change.
have like oil and like oil and balsamic? You know, when like you go to the place and it doesn't mix in. What's that? The mixture?
That's about density, but there's still mixtures, right? There'd be a type of mixture. They'd just be really separate mixtures. They'd be called heterogeneous mixtures.
And the density, it floats if it has a higher density, right?
Mhm.
Okay.
A lower density, it floats over
Oh.
the higher density.
So
Because
floats.
heavier density, more dense it is, you sink down.
So the lower the density is, the higher it floats.
Yes.
That's why the salt water was like more dense.
Right.
Okay, wait, and then like
No.
what's the thing with homogeneous and
Right, let's talk about that now. We got the mixtures. We got a couple types of mixtures. One type is a homogeneous or homogeneous. Those are the uniform mixtures. They all are very evenly distributed. All the little substances in them are evenly distributed. And the other kind of mixture is the heterogeneous mixture, which is a whole bunch of different stuff mixed together. And you can easily tell that one part of the mixture is different than another part of the mixture. That's stuff like smoothies or like the oil and vinegar. Okay? The homogeneous mixtures, back to them now. Those can either be solutions or they can be colloids. The homogeneous mixtures that can either be solutions or colloids. Those solutions are really small substances mixed together. It's so small that you can't even see them, like
Like
salt
fog.
water and water.
What about fog? You said fog.
Fog is a colloid.
Yeah.
That's a colloid. So that's slightly bigger stuff. mixed in. You can see it by shining a flashlight through it or headlights through fog. You can see the colloid.
Okay.
Wait, but colloid and solution means that like you can't see the two parts of
A solution you can't see the parts. Colloid you can if you shine a light through it, and you can also just like see the like little tiny. You can see fog, right? You can see smoke.
And what's the suspension?
Suspension is something where you have two distinct, easily separate parts in a mixture. You
Isn't
can
that like wait, but then if you like is there a difference between saying like this mixture is a suspension versus this mixture is a heterogeneous mixture? Are they like the same thing?
they're the same thing. Yeah. That's a good question to ask. A heterogeneous mixture can also be called a suspension.
Can you ask that question?
Maybe.
Wait, I didn't write that. Can you write that?
Without
A heterogeneous mixture is also known as a what?
Suspension. A homogeneous mixture can be called a colloid or a solution. There's synonyms.
Can you
Let's talk about that last problem then, okay? Is that physical change and chemical change, and then we'll be done?
yes.
Okay, physical change. These things are very vague. Physical change. Physical change is anything that is. Now let's define chemical change better. A chemical change is when the small parts, okay, the elements, are rearranged in some way. So a substance changes, and that's a chemical change. So, like, let's say you take water and you put electricity through it, or you somehow split away the oxygen from the hydrogen. By taking those things away from each other, you're chemically changing it. You're not physically changing it. Physically change it would be to take a whole bunch of water and evaporate it. So that way you'd still have water, it would just be in a gas form rather than a liquid form.
What's a chemical change? Like an example.
Just like I said, by splitting water into different pieces. Let's say you take, I don't know, you do. Let's say that you take, we haven't gotten into this yet, but an acid and a base, and we combine them together, right? You'll get something we call salt, and you also get some water. So that way, it's almost like magic. You're taking substances, and you're taking their pieces apart and recombining them into something else. That's what happens with rust. That's what happens in your digestive system. Those are all the examples I gave you before. The tiny parts are rearranging themselves. That's a chemical change. And I make it very obvious in the test what is a chemical change and what's a physical change. As long as you know it's the parts are the things that are rearranging, that's a chemical change.
Remember
Yeah.
that's why you have things in this steam?
Yeah. It's not chemical because the water isn't changing its parts. All it is just water now spread out a little bit more.
So whenever it completely changes,
Yes.
it's chemical.
Yes. Yes.
Like, you gave an example of milk sours. How's that?
The milk souring, that is what's happening there is bacteria is taking some of the. I mean, if I was more specific with that example, now I'm thinking about it, I should be more specific with that example and say like the bacteria take a certain sugar and then consume it and then spit out a different type of sugar as a product. That's what happens in sours.
Food is digested in the stomach. That's what, like, I thought that was a physical change.
Because the acid in your stomach, right?
Yeah, it's the acid that's recombining with the materials in the
Using
stomach.
all the biological stuff.
Yes, I know. So that's why like these questions right there, there's actually not the best questions in the world, even though that's whatever. I mean, I'll make it very, very simple for you guys to see on the test. Okay?
And for like multiple choices, where we have like multiple things to circle, like the fact history.
Yes. You like circling?
Great.
Okay. Do you let's you know
Yeah,
what?
can we do the last problem?
The last problem, and then is that okay? Can we go?
Yeah.
All right. All right. Let's do that then. Okay, here it is. Tommy has a balloon and it's exactly 121.82 centimeters cubed. What is the maximum mass a balloon can be? Still float in the air. Report your answer in grams. The density of the air is 1.2041 grams per meter, or kilograms per meter cubed. Okay, so this one's tough. Basically what you have to do is you have to first convert the density of air into the right units.
What is the density of air?
The density of air in here says 1.2041 kilograms per meter cubed. But we want to know what that is in grams per centimeter cubed, so we can compare what the balloon is. So here, so if you want like a roadmap to this, I can tell you're a little bit tired, it's like the end of the day. But if you want a roadmap to this, here's what it is. You know what the density of air is. Okay. You're trying to find out if this density of air, or what will it take, basically? What will it take? What mass goes into here in this density formula? It's volume over density. I'm sorry, mass over volume. What mass will equal air's density? That's what we're wondering here. So we've got the density of air, and here's the density formula over here. We've got a balloon that has a certain volume right here. And we want to know what mass of that, what's the mass of the balloon, so it'll equal air's density. Because we want it to float. So this question's, I don't like this question so much, I'm not going to use it again. Because it's just not, it's not clear what I'm asking you to do, really, unless you sit there and think about it for a little while. So in a test situation, you're really stressed anyway.
I mean, I think I set it up right. I just want to know. Can I show you what like I got wrong? Can you just explain?
Sure.
But it's not really good.
So what I'm going to do then, I'm just going to turn this off.
Okay.